All right, so in this video, we're going to talk about function composition. So we're going to do number 18 here and then do 9 through 12. So it says for number 18, the piecewise linear function f is defined on the interval from -3 to +3. We can say the closed interval from -3 to +3 is shown in the graph below. Function g is given by g of x equals to x minus 2. You want to sketch a graph of y equals f of g of x. So we call this function composition because there's one function inside of another function. But also what you're going to see is that we're going to then use the information here to go back to function translations, as you're going to see. So we know g of x equals to x minus 2. So we can replace the g of x with x minus 2. Therefore, we have f of x minus 2. And from previous sections, we know that this means that we're going to shift graph f 2 units to the right. That means shift the graph 2 units to the right. So we're going to shift every point on this graph 2 units to the right. So I'm going to start at the bottom with the bottom set of coordinates, move 2 units to the right. Every point is going to move 2 units to the right. The point that's up here, shift that 2 units to the right. And then the last point, which is -3, 2, shift it 2 units to the right. And then graph. And so this graph right here is y equals f of g of x. And that is all. That is how you sketch the graph f of g of x. Now, we have two rational functions. F of x equals to 3 divided by x squared, and g of x equals to 1 over x. And I want to find the composition of f of g, state its domain, find the composition of g of f, and then state its domain. So I'm going to go up here and remind the audience that when we see f of g, it is the same thing as saying f of g. In this case, the variable is x. So we can rewrite f of g as f of g of x. G of x equals to 1 over x. So we can write that as f of 1 over x. What does f of x equal to? F of x equals to 3 over x squared. 3 over x squared. But instead of us putting x, we're going to put 1 over x. So that means that f of g is going to equal to 3 over, well, that's going to be 1 squared is 1, and x to the second power is x squared. So that's 1 over x squared. Now what I'm going to do is, before I do any other math for my domain, I'm going to take the function 3 over 1 over x squared. I'm going to put that over here. That's going to help us for our domain. But when we divide by a fraction, we can change that to multiplication of the reciprocal by utilizing what is called keep, change, flip. So that means you're going to keep the top term the same, which is 3. You're going to change your fraction, which is division, to multiplication. And then you're going to reciprocate or flip the second fraction, which is x squared over 1. But x squared divided by 1 is just x squared. So it's going to equal to 3x squared. The domain of the function comes from before we utilize keep, change, flip, because we have a variable in our denominator, and this is a fraction, and we should know from unit 1 that our denominator has a restriction. So for our domain, we should know that our denominator, which is 1 over x squared, cannot equal to 0. Because if our denominator is equal to 0, then our function is undefined. But this is still a function. Rather, this is still a fraction. And once again, because this is still a fraction, we should also know that once again, our denominator, which is x squared, that cannot be equal to 0. Now, I do want to say this. 1 divided by x squared can never be 0. 1 divided by anything is never 0. So that itself is not a restriction, but the restriction comes from the x squared in your denominator of your fraction. X squared cannot be equal to 0. So then by taking the square root of both sides, we learn that x itself cannot be equal to 0. So our domain can be any real number except for 0. So in interval notation, it is parentheses, negative infinity to 0, union 0 to infinity, and everything gets parentheses. Because the values are excluded, so they get parentheses. Now we're going to do the same thing for g of f. So that's going to be g of f of x. F of x equals to 3 divided by x squared. So we're going to replace the f of x with 3 over x squared. G of x equals to 1 over x. So it's going to be 1 over x. But instead of putting x, we're going to put 3 divided by x squared. And I want to hold on to that. So I'm going to write it over here. 1 divided by, that's a 1, by the way, not a 4. 3 over x squared. We're going to use that for our domain. Anyways, we're going to utilize keep, change, flip once again. So keep the top the same, change the division to multiplication, flip the second fraction. So g of f equals to 1 times x squared over 3. And 1 times anything is itself. So that's going to be x squared over 3. Or if you want to, you can write that as 1/3 times x squared. Same thing. And once again, our domain, because this is a fraction, our denominator for our domain states that 3 over x squared cannot be equal to 0. Now, 3 divided by x squared will never be 0, but it's also a fraction. So that means that still x squared cannot be equal to 0, and is basically the same domain as the last question. So the domain is any real number excluding 0. So that is it to our function composition part of our final exam. The questions will be similar, but a little bit different because you know I love a twist. The next section will be inverse functions, and that's only exclusive to first period. But then the other sections will be every period. So we're done with section 2. How many videos were that for section 2? So 1, 2, 3, 4, 5 videos for section 2. All right, guys. I'll catch you in the next one. Peace.